In today's lecture, we will discuss Lissajous figures. Which arises as a result of superposition of two perpendicular simple harmonic motions or oscillations. We will discuss various cases. Let us take up case 1. We consider two simple harmonic motions or oscillations given by x equal to a cos of omega t and y equal to also a cos of omega t. So this is along x-axis and this oscillation or movement is along y-axis. So they are perpendicular simple harmonic motions or oscillations. It is clear that motion will occur in the xy plane. Let us eliminate t from the two equations, which is a very easy task because y and x are same. So we can write y equal to x, which is t eliminated equation. And this equation y equal to x represents a straight line having slope unity, and one is tan of 45 degrees, so it corresponds to a straight line inclined at 45 degrees to the x-axis. The intercept is 0, so the straight line will pass through the origin. So we conclude that the pattern, which is called Lissajous pattern, will be a straight line in this case passing through the origin. For this case of two oscillations which are perpendicular, having same frequency and are identical in form. So this is an important thing to note, that they have same frequency. Also they have same amplitude, but one along x and the other along y. Let us now draw the Lissajous pattern or figure, which is a straight line, and also investigate how this straight line is traced. Suppose this is omega t. Here let us place x equal to y, and we will indicate the points or the coordinates which are x, y. Now for t equal to 0 or omega t equal to 0, we have the value of x to be a, and similarly for y. The coordinates are a, a, and let us make a plot here. This is x-axis, this is y-axis. This is plus a, this is minus a along x, this is plus a along y, and this is minus a along y, and this is the origin, which is 0 0. So AA corresponds to a point here, which we denote by P. So this is P. Then for omega t equal to pi by 2, cos pi by 2 is 0, so x is 0, y is 0, and the coordinates are 0 0. So we arrive at the origin, and let us call it O. At pi, cos pi is minus 1, so it is minus a. So the coordinates are both minus a. This corresponds to a point here, which let us call Q. So it is Q. Then for omega t equal to 3 pi by 2, cosine is 0. So the coordinates are 0 0. So it is at the origin here, and then at 2 pi, cos 2 pi is 1, so it is a. Coordinates are a and a, so we are back to P. So we are in a position to identify the plot, the nature of tracing from P to O, then from O to Q, then Q to O back, and next from O to P. So this is how the resultant motion occurs, P to O to Q to O to P. So this is how the Lissajous figure is traced. We now consider the second case, case 2. We will consider two simple harmonic motions or oscillations. One is given by x and the other is given by y, and they have the form cosine and sine, and therefore there are four possibilities. So case 2a is x is a cos omega t and y is a sine omega t. The second case is x is minus a cosine omega t and y is a sine omega t. This is say case 2b. Another possibility is x equal to a cosine omega t and y is minus a sine omega t. Let us call it case 2c. And the fourth one is minus a cosine of omega t and y is minus a sine omega t. And let us call it case 2d. So we will solve four similar type of problems. Let us rationalize the equations. Let us divide x as well as y by a to get so for case 2a we get simply cos omega t, and here we have sine omega t. For case 2b we have minus cos of omega t, and for y we have sine omega t. For case 2c we obviously have x by a as cos omega t and y by a as minus sine omega t, and the last option is minus cos omega t minus sine omega t. It is clear that the oscillations occur along x-axis and y-axis simultaneously, so the resultant motion will occur in the xy plane. This is clear, and let us find the t eliminated, t is time, t eliminated equation. In all the cases, the value of x by a whole square plus y by a whole square is cos square plus sine square, the sum of which gives us 1. Or in other words, we have x square plus y square equal to a square, which is obviously the equation of a circle. So this is the equation of a circle whose radius is a and whose center has coordinates 0, 0, because it is x minus 0 whole square and it is y minus 0 whole square. Obviously, due to superposition of these two oscillations, which are mutually perpendicular to each other, the pattern, also called Lissajous figures, that is generated is a circle for all the 4 cases. And let us first discuss how the circle is generated and how it is traced for the first problem, which we have denoted by 2a. In case 2a, let us plot omega t here. X is a cos of omega t, y is a sine of omega t, and due to superposition, the resultant vibration will move through various points, the coordinates of which will be x, y. And we'll make a plot. This is say x-axis, this is the origin, this is plus a along x-axis, and this is minus a along x-axis, and this is the y-axis, this is plus a along y-axis, and this is minus a along y-axis. Now for omega t equal to 0, x is a and y is 0, so the point is a0, and let us call this point P, which is, this is a 0 point, so let us call it P point. For omega t pi by 2, cos pi by 2 is 0, so this is 0 and this is a. So the coordinates are 0, a, which let us call q. So this is 0, a, let us call it q. So the resultant vibration moves along a circle from P to Q in this manner. Though it is obvious that the remaining portion of the path will be circular, that is, we will move from Q to P passing through these points. Let us verify the thing. So now omega t is pi, and then x is minus a and y is 0. So the coordinate is minus a 0, which is R point, say, and this is the point R. So this is how we come here, and then 3 pi by 2, whence cosine is 0 but sine is minus, so we are at 0 minus a, and let us call this point S. So we are here. So the circular track goes like this, and finally at omega t twice pi we arrive at this point, that is back to P. So this is the Lissajous figure that is generated for the case 2a, which is a circle. And what is the nature of its tracing? It is clear that the circle is traced in this manner. Now, is it anti-clockwise or clockwise? Is it left-handed or right-handed? That depends upon who is viewing it and from what location one is seeing it. Now this is x-axis, this is y-axis, and the z-axis is towards the reader, that is away from the origin. Now we are observing it from the top, that is we are looking at the origin, which means we are looking along minus z. So when looked back, that is when looked along minus z, the tracing is anti-clockwise and the motion is right-handed. So let us write it clearly. Looked along minus z, the motion is, or the tracing is anti-clockwise or right-handed. So it is clear how will one view it. If one views along z-axis, it will be just opposite to it. So when looked in the front, this is looking back or looking down. So when looked along z-axis, that is looking at the front, towards the front, that is looking towards the top and not from the top, the motion will be clockwise. The tracing will be clockwise or left-handed. Now what about the other circles? That we will do now. Now these are the 4 cases. We will plot omega t. This is x, this is y, and this is the points x and y. So this will correspond to case A, this is case B, this is case C, and this is case D. We will write down the values of omega t, values of x, values of y corresponding to omega t, and the points will be written over here, and we will draw the diagrams here. So the plots are to be done here. For omega t 0, x in case 2a is a and y is 0, and for omega t pi by 2, cos pi by 2 is 0, so x is 0 and y is a because sine pi by 2 is 1, so this is a. So the points are a is 0 and here it is 0a. So the movement is from this to this point, which we will show in a plot. This is x-axis, this is y-axis, and a0 is a along x and 0 along y, so we are here, and 0a is, it is 0 along x and a along y, so we are here at this point. Let us call this point P, and this point is q. So the movement, as stated earlier, will be from P to Q, and the rest portion will be just join them by means of a circular path or track, and this is it. So the movement is along this direction, this being the origin, and this is plus a along x, and this is plus a along y, this is minus a along x, and this is minus a along y. We next come to the second problem of 2b, according to which for omega t equal to 0 we have minus a and y is 0, so that the point that we get is minus a 0, and when omega t is pi by 2, x is 0 because cos pi by 2 is 0 and y is a, which leads to the point 0a. So now the movement will occur in this manner. Earlier it was from P to Q as indicated in this diagram, and now we have to draw a similar diagram. This is x-axis, this is y-axis, this is a minus a along y, and this is a and minus a along x, and this is the origin 0, 0 point. Let us identify minus a 0, which is this point, minus a along x and 0 along y, and let us call this point R, and the point 0a is 0 along x and a along y, and 0a is 0 along x and plus a along y. So this point, which is q, so the motion is now in this direction, and we can just join the points by a circular track. So this is how the motion occurs, which obviously is different from the earlier one. We now move on to the third problem of 2c, in which for omega t is 0, x is a and y is 0, and for omega t equal to pi by 2, cos pi by 2 is 0, and this is minus a, which means now we are moving from a 0 to 0 minus a, which is different from the previous one where we moved from R to Q. Now let us check how we move in this case. This is x-axis, this is the origin, this is plus a, this is minus a along x, and this is the y-axis, this is plus a along y, and this is minus a along y. So a0 is plus a along x and 0 along y. So we are right here, which we denoted by p, and 0 minus a is 0 along x and minus a along y. So we are here, which we denote by s. So now we are moving along this direction, and we can join these points through a circular track. So this is how the circle is traced in the third case, which is actually 2c, but it will be different in the case of 2d, where omega t, if 0, x is minus a and y is 0, and for omega t pi by 2, x is 0 and y is minus a, which means we are moving from point minus a 0 to the point 0 minus a, which is different from the previous one where we moved from P to S. So let us plot as before. This is x-axis, this is the origin, this is a, plus a along x-axis, minus a along x-axis. This is y-axis, plus a along y and minus a along y, and minus a 0 is actually minus a along x and 0 along y. So we are here a point which we named R, and from here we have to move to 0 minus a. So 0 along x and minus a along y. So here, which means we have to move along a circular track from R to this point, which we denoted by S. So this is how we move, and the rest part we have to join by a circle. So this is how we move, that is from R to S. Let us now mention how the circles are traced. Is it anti-clockwise or clockwise, or in other words, is it left-handed or right-handed? Regarding the nature of tracing, that is clockwise or anti-clockwise, left-handed or right-handed, we have to clearly mention who is viewing it and what is his or her location. Suppose this is the z-axis. This is x, this is y, and this is z. That is, z axis is from the bottom to the top, that is towards the reader, for it to be a right-handed coordinate system. So if viewing is along minus z, that is when we are looking back, when we are looking from the top towards the origin, then what we see is as follows. So viewing is along minus z, then obviously this motion is anti-clockwise or right-handed, and this is clockwise or left-handed. This motion is also clockwise or left-handed, and this motion is anti-clockwise or right-handed. But the conclusions will reverse if viewing is changed. That is, if viewed along z-axis, then the conclusions will be exactly the opposite. So along plus z, so the conclusions now will be clockwise, this is left-handed, this is anti-clockwise, right-handed, this is anti-clockwise, right-handed, and this is clockwise, left-handed. We have been able to plot the Lissajous figures for the 4 problems 2a, 2b, 2c and 2d, and we note that they are circles, and this is how the circles are traced. We have proved them, we have derived them, and we note that the circles are traced similarly, that is both anti-clockwise or both clockwise, if x equal to cos and y equal to sine both are preceded by either a plus sign or a minus sign. Again, the tracing will be identical, that is both clockwise or both anti-clockwise, depending upon who is viewing and from where. If x is cos and y is sine and they differ by a negative sign, that is one is minus, the other is plus, one is minus, the other is plus.